Okay, kids, welcome to video 3 of Earth Out of Class. So we've got a few people here in the classroom who braved COVID to come in, and we're going to do a lesson today. We're going to continue our lesson on volcanoes, and I'm just going to go back over some of the stuff that we talked about in class. So when we think about volcanic eruptions and volcanic features, we think of 3 words, and those words are what, class? Effusive, fumarolic, and Jade? Paroxysmal. Paroxysmal, good, very well done. All right, so let's start with effusive. Effusive. So effusive activity is what type of activity, Tom? It's lava. All right, and so let's talk about lava. Our lava can come in different forms. We'll start with a mafic lava. Now, we've already talked about how we get our different types of magma and lava and the rate of cooling. So let's actually talk about them, I guess, and the features that they've got. So you should be at the lava, I think it's page 9 of the PowerPoint. And we've got, talk a little bit about pahoho. Oh, let's give this one, let's call this mafic lava. I'm gonna go with mafic. Now, our mafic lava comes in 2 forms that we really know well, and that's called pahoho and RR. But there is a 3rd type of lava that we get, or 3rd type of mafic lava, and it's one that forms underwater. And this is a pillow lava. So it's a basaltic lava, or mafic lava, or basic lava, if we're going to call it that. And pillow lava sort of forms in these, how can I describe it? Let's draw it over here. We'd have the surface of the water, and we would have a small vent underwater. And lava makes its way out, but as it makes its way out, it cools virtually instantly. So more lava flows over, and you end up with these round pillows. Where the lava forms, and this is pillow lava. And literally, some lava will move out of the water, it'll solidify and harden straight away. So it doesn't get the chance to flow like it would on the surface, but it really comes out in these little short pillow lava blobs, if you will. So pahoho, RR, and pillow lava are all types of basaltic lava. And when we think of basaltic lava, there are 2 locations where we get those. Firstly, hotspots. Now, you might remember from our last video lesson, I talked a little bit about hotspots, and there's actually about 35 or 40 hotspots around the world. One of them is in Hawaii, and a mountain called Mount Kilauea. Mount Kilauea is about 9 kilometres high, if we're talking about off the sea floor. Which makes it the highest mountain in the world if you got rid of the ocean. The other place you get basaltic lava is in divergent boundaries. So if we're thinking back to our pillow lava up here, divergent boundaries at spreading ridges or mid-ocean ridges is where we're going to have those these pillow lavas form on a massive, massive scale. But another place where we get that today is in Iceland. Can anyone name me a volcano in Iceland? There's one. What was that, Holly? Eldfell. Yep. Mount Eldfell. There's another one called Helgafell. And then there's everyone's favourite. Oh my God, got to spell it now. I can't remember how to spell it. Okay. I have to Google it. Hang on. It is Aya Fala Yokul. If you ever go to Iceland, make sure you go to the McDonald's museum where they have, I think it's about 10 years old, a burger, a cheeseburger and fries that's been, not been touched for 10 years, and it's actually still in very good condition. A little bit of Icelandic info for you there. And, okay, so basaltic lava, sometimes it's called mafic lava. Sometimes it's called basic lava, not lager. And sometimes it's called, but basaltic. So they're the three names that we use for lava in hotspots and divergent boundaries. Another hotspot that's actually doing something at the moment is in America, and it's, with the bear who lives, I can't believe I'm saying this. Sorry, can't think of the name right now. Yeah, I know, that's weird. The name of the volcano, I'm sorry YouTube for this mishap. Sorry? Yellowstone National Park, thank you. Oh my God. There you go, Yellowstone National Park. Actually, it's having a little bit of eruption. There's a lot of activity going on there at the moment. So it certainly would be one to look at. Right, let's go on to some different types of lava. Actually, before I do, I will say one thing about basaltic and mafic lava. Is that it has a very high ferromagnetism or ferromagnesium amount. So it's high in ferromagnesium or metals. High in iron, aluminium, magnesium. This is important later on because basaltic magmas and even ultramafic magmas contain a lot of, precious metals that we access nowadays. All right, let's get over and let's talk about felsic magmas. Now, felsic magmas are the bad boys of the mafic or the volcano world. You'll see just after RR, there's a slide on felsic magmas. So what is it about felsic magmas? Well, firstly, it's very high in silica. High in silica. When we think of silica, we think of SiO2, silica dioxide, which otherwise we know as quartz. So what do we know about this type of magma? Well, and this type of lava, it's very viscous. It's very thick and does not want to flow. It's resistant to flow. Why is it so resistant to flow, Alia? Literally because it's so thick, it does not want to move. Now, generally, the thixotropic nature of a lava means that when it moves, there is shear movement which thins it out. But felsic magma does not allow that to happen. It's still just too thick. So it's resistant to flow and nearly a solid. It has features of a solid. I'm not going to write that down though, but just something to know. When it forms in a volcano though, it forms these features called lava domes. And if you look at the slide on felsic magma, you can see I've put 3 lava domes on there. The bottom right one is in Mount St. Helens, and it's a very felsic and very active and violent volcano. We'll talk about a bit more about how Mount St. Helens erupted, but it rather than forming lava flows, it builds up in this high sort of peak, if you will, of magma that just refuses to flow. It does not want to flow. So it just builds up, this lava that just builds up and up and up. It stays fairly solid. So you also get features called lava spires or spines. And they look like little peaks on the top. It's lava, but it's very much like a solid. And what happens with some of these peaks in our lava domes, or on top of our lava domes, if you will, is they will fall. And when they fall, they pulverize straight away into volcanic glass and rock. And they fall as pyroclastic flows down the side of the volcano. They're very violent, and they're very indicative of a felsic volcano. And if we think of volcanoes like Mount Asuma in Japan, Montserrat in Caribbean, Mount Pelée, and that's also in the Caribbean, and pretty much any volcano in Indonesia has the ability to be this sort of type of violent volcano. All right, that's it with felsic lavas. So felsic lava features are lava domes and lava spines or spires. Mafic lava features are pillow lavas or pahoho or RR. All right, that's lava done. I'm going to stop the video, and the next one we'll talk about gas.